Hello, everyone. This is Mr. Harris. I just wanted a little bit of intro music. Why not? Okay, so in this video, this is a video for class for Thursday, October 15th. I will go ahead and also make this video available for classes for Friday, October 16th, because we're going to cover the same things. So I'm in page 11 of your guided notes. Try your best for pages 11 through 12 to do this on your own and then check. The solutions will be posted, page 11 through 12 solutions. A big part of this is developing your critical thinking skills, making connections, what type of symmetry, how is the graph related to the graph, especially questions like this. This is a wonderful question. I even highly suggest you do this on your own, answer it, and then check the answer. Lots of light bulbs will be going off. So page 11 through 12, I will try in the announcement for the class to say pages 11 through 12 I'm working through, and I'll stop 5, 6, 7 minutes in, however that is. 13 and 14 look familiar. We worked on that last class. Page 15 through 16, I'm going to work through what we did not cover last class. We did A and B. The answers will be posted for pages 15 through 16 answers. I will do C. I'm going to also do D. I did D for some classes, but I don't think I did D for 1A, so it's there. Again, I'm going to do E and F, I and J. I already did these. I will discuss these because I already did them for classes. And again, feel free to play it at twice speed, 1.5 is fast. Advance, it's up to you. If you want to do this completely on your own and then check the answers, fine. Power's up to you, whatever works for you. I'm going to discuss piecewise functions again. These notes are for you. I'm also going to work on this. This is really practice in writing equations of straight lines, believe it or not, and piecewise functions. We will discuss functions and do function dances in class beginning Monday and Tuesday of next week. I think next week, 16, 17, 18. Next week's the week of October 19th. Just to keep the momentum going, because this is really how much I wish I could cover per every class. I'm going to use this as a test for myself. How long does this really take to work through? So page 20, I'm going to cover all of this. For those of you that turned in your homework, this should be essentially a review. We're going to learn the language of describing graphs. So before I go back to page 11, that's the absolute value function. Always imagine what they look like in your head. And then I'm going to start with page 11. Let me organize. Get my pen. Okay, I'm off from page 11. I'm going to make notes. Okay. 602 pages 11 through 12. Okay, so page 11, as we discussed in class, last class, whether it be Monday or Tuesday, we're discussing transformations of absolute value functions when the absolute value is inside parentheses. So we're going to be augmenting the x values, the input x values. Remember, x is always the input, it's the independent variable, y is always the output. You notice we're constantly harking back to pre-algebra stuff because it all connects. Suppose 2x minus 5, we're given f of x equals 2x minus 5. We're told to graph f of x, which is 2x minus 5, and the negative version of f of x. I'm just going to write this down, 2x minus 5. That will go into my y1. And then I'm going to graph 2 parentheses, 2 times the quantity negative x minus 5. And as we discussed in class, there is a difference. So let me go clear out whatever I have. 2x minus 5, and then 2 parentheses, negative x, end parentheses, minus 5. Double check, graph, that's 2x minus 5, 2 times the quantity negative x minus 5. the same thing happened. It reflected over the y-axis, just like we would expect. Multiplying the x values by a negative number reflects it over the y-axis. So I will do one in a cool color and one in a warm color. Okay, I'll do purple and orange. I'll do 2x minus 5 in orange, and then the reflection of that over the y-axis in purple. Again, just to remind you, 2x minus 5 is in y1, so when I do second graph, y1, so I'm going to plot coordinates from y1. I'm just plotting enough coordinates to get the job done. I do have to move my calculator to give myself enough room to write. I'm choosing obvious clear-cut coordinates. Let's do, you guys are good with that. 2, -1, 1, 2, -1, 4, -3, 4, no, 4, +3, 1, 2, 3. You only need 2 points to draw a line, but it's always good to have a few extra just in case. -2, -1, 2, 3, 4, 5, 6, 7, 8, 9. I'd like to get the y-intercept too. 1, 2, 3, 4, 5. And there has to be an x-intercept, but it's not a nice, easy number, so I'm not going to bother. It'll be close enough. Let me just get 7, 9, just to 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, hopefully you sped through this. I'm just plotting points. Remember, as a teacher, I have to consider all the students involved, and there might be some students that needed me to go through that more slowly. Let's see, I think it's 85 pre-calc students. Always try to use a straight edge because it is a line. Typically, I would label it down here, but since it's color-coded, that's good enough. But why not, right? Why not? F of x equals 2x minus 5. Let me do the purple one. And I'm moving my cursor here just to keep track of what things are and where they are. Okay, here we go, okay. I do need the cursor because I don't want to make careless mistakes. -5, 5, -1, 3. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. -3, +1. 1, 2, 3, +1. 0, -5. And that's where they overlapped at the y-intercepts. 1, -7. Let me try to do one that's further out to save myself a bit of time. I'll do 2, -9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Dun, 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 dun. I'll do f of -x equals, too much I have to write, but just to be consistent. That's why it's nice to color code. We're definitely talking about absolute value functions. We're going to essentially connect, slightly in a slick way, derive the absolute value function, which is essentially you get the line y equals x, then reflect that line, and then constrict the domains. So now for B, we're going to graph f of x is still 2x minus 5. So we're going to plug the absolute value inside parentheses. So it's going to be 2 times the quantity absolute value of x minus 5. So what I'm going to do here is I'm going to just type it in. I'm going to get rid of my parent function 2x minus 5. So to type in the absolute value, I do 2 parentheses, second math. Again, second math obviously isn't there. So math, move over to number, ABS, absolute value. It looks like this in 84, as in 83, it'll say ABS parentheses. You still type in X, move the arrow to move it out, and then close parentheses minus 5. graph just for the heck of it to see what it looks like. And we all know what absolute value equations do. Why am I typing in my parent? To take that time to analyze. A big part in math is stopping and analyzing what's my answer, why is it different? So the original function was here. We learned in last class the transformation of the absolute value of the input variable x. Whatever's to the right of the y-axis stays put and is copied and pasted over. Anything that was to the left of the y-axis, meaning negative x's, are just erased because that's how it functions. And you saw typing it in, that's how your program, your computers, or sorry, your calculators are programmed to graph it, because that's what actually happens to the function. Again, see each function as a machine. I don't know what 2x minus 5 does. It's a relatively simple machine, but it's a machine nonetheless. So now that we've discussed that, let me delete this because I don't want to mistakenly add the wrong coordinates. And now I'm just going to plot some coordinates. Notice that 0, -5 is still there. 4, 3, 1, 2, 3, 4, 1, 2, 3, 1, 2, 3, 1, -2, -1, 1, 2, -1, and get a few more. Negative. So 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7. That's good enough. Okay. Okay. Here we go. Straight edge to the rescue. For those of you that did your second problem set, Lady Straight Edge, that's one of your heroes with the superpowers or what have you. Make sure you meet with me during tutoring on Wednesdays from 10 to 11. If you have questions or if you want me to walk through the first part of that, if any of you want to get ahead on tutoring. Yeah, so I mean, that's it. Suppose now we have a quadratic equation. It's going to work out very similarly. I'm graphing this because I'm here, but I hope you're just graphing on your own and you're checking the post-it key. At this point, you guys know how to graph. X squared minus 6x plus 5. Yeah, graph. Looks something like that. Second table. And I'm going to do the same thing. I'm going to graph this new f of x in orange, and I'll do the other one in purple. 0, +5. 1, 2, 3, 4, 5. -1, +12. 1. I think that's going to go off. So let's see if I have others. Yeah, I'm going to use others. 1, 2, 3, 4. 1, 2, 3. 1, 2. Oh, cool. 1, 2, 3. And then 4 or 3 is -4. Okay, so it's nice we have the minimum value there. I'm going to graph some more higher points. I have 6, 5. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. 6, 5. Okay, that's good enough. If I went out, it only goes up to 10. I'm going to add a ghost point, if you will. I'm going to add -112. It's somewhere up here, just to help me keep track of. Okay, here we go. It's going to be something like that. Quadratic equation. Now, one thing I'm going to do is I know that the negative sign inside parentheses means this is going to be reflected over the y-axis. So what I'm going to do is, I think I plug -x in for this x and this x, because that's the nature of function notations. It's f of -x, so I place that with both of them. For the heck of it, I'm going to type in a -x squared, but leave this x alone so we can see it probably won't come out right. But it will be a very good learning opportunity. Minus 6x plus 5. Okay, so let's see what's going on here. It's not even graphing it. Who knows what's going on? Let's see if there's something in the table. It's there. It just looks like it's really, I'm noticing it's the exact same points. Let me triple check. Negative x squared minus xx5. It gave me the same points. Before I jump to conclusions, let me retype it to make sure I didn't type it in wrong. I am shocked that it's the same graph. I was expecting that negative in front of the x to do something. However, a negative squared is positive. So generally speaking, maybe this undoes the negative. So maybe the magic happens when we make this x negative. I'm not certain. But we do know that a negative square is positive. So I'm thinking that's why nothing's happening. And this is what can happen by doing explorations like this. You're sort of dissecting these equations and seeing what's really going on. So let me change this to minus 6 times the quantity negative x, in parentheses, plus 5, graph, first graph. Oh, so wow. Plugging in this as a negative, we saw didn't do anything because -1 squared does cancel out. If you look at the generic parent function for a quadratic, it's definitely symmetric over the y-axis. So technically, a reflection over the y-axis, if the f of x equals x squared, f of negative x still equals x squared. A reflection over the y-axis is identical to the original function. And this is what we call an even function, where if you take f of the negative version, it looks exactly the same. And we know x cubed is an odd function, f of negative x. X cubed looks something like that. F of negative x would reflect it and look something like that. So now you see how through this exploration we discovered even functions, odd functions. You find when you're dissecting these equations, you're finding all the interconnectedness between these graphs and these functions. So now that it worked out, and that really does matter, I'm going to, I don't want to deal with that function there. So I'm just going to, just in case you were graphing, I just want to look at it again, why not? And it's looking like this, oh, shame on me. I deleted the other one, but it would have looked like a W or something. So let me just go to the table and plot some coordinates. I'm thinking the same magic is happening around the y-intercept, and it certainly is, 0, 5. -1, 0, so we have a y-intercept. -3, -4. 1, 2, 3, 1, 2, 3, 4. -2, -3, 1, 2, 3. I think that's going to be the same thing. -6, -5, 1, 2, 3, 4, 5, 6. Oh, -6, +5. 1, 2, 3, 4, 5. Okay. Okay, so it's going to look something like that. Bam, bam, bam. We already discussed it. Now let's jump to B. And we also know that if we're going to take the absolute value of this x, it has to be that x. It's all the x's in the equation, hence function notation. So let's just graph that. I'm going to go ahead and erase this and just type this into y sub 1, parentheses, math. Let me just do it. Parentheses, math, number, absolute value of x, close parentheses squared, -6 parentheses, math number, absolute value of x, close parentheses, +5. Let's triple check. Hooray, hooray, hooray. There it goes. Graph. Oh, look at that. So it did that for us, except it got rid of all those extra bits and pieces. So essentially, it took the original function in orange. Whatever was a positive x, it copied and pasted it over. And it deleted whatever was originally a negative x. And we see very similar coordinates here. 0, 1, 2, 3, 4, 5, negative 1, 0, 3, okay. Negative 2, 1, 2, 3. This will be 4, this will be 3. Okay. 1, 2, 1, 2, 3, 4, 3. Oh, we got 5, 0. Yep, 1, 2, 3, 4, 5. You can even see the reflection. We have a root at 5, 0, and we should have a root at negative 5, 0, which we do. 1, 2, 3, 4, 5. Okay, that's enough. Just remember it stops here, comes down. Hooray, hooray. Yay, we're exploring mathematics. And that's it for page 11. On to page 12. Okay. For the functions above, meaning above, so if that's 3, this is 2. How does the graph of the absolute f of the absolute value of x compare to the graph of f of x to the graph of f of negative x? So take some time and try your best to actually write this out in your own words. You actually will benefit immensely by trying to do that. And just looking at this, the absolute value of x matches f of negative x, except it excludes values of x that were negative on this side, and it excludes values of x that were positive of this one. Or a better way is just it takes the positive orange x's and copies and pastes them over. That's. I'll take the time and write it out so you don't have to go check the key. Okay, so the graph of f of the absolute value of x matches y equals f of x for values of x greater than or equal to 0, or essentially right of the y-axis, and matches y equals f of negative x for values of x less than 0 or left of the y-axis. Good job, we get it, great job. On to this number 4. We're given f of x. In this case, they're giving us the function in terms of a graph instead of in terms of function notation. And now let's try one without the calculator. Given the graph shown below, sketch the graph of, we're just reflecting over the x-axis. I mean, not the x-axis, the y-axis, because you're changing the sign of the x values, positive, negative. If it's positive, it'll be negative. If it's negative, it'll be positive. If the x value is 0, nothing will change. So 2 to the right, therefore it's going to be 2 to the left. I have a coordinate 3, positive 3, positive 1, so it'll be negative 3, positive 1. 1, 2, 3, 4, 5, 5, negative 2. So 1, 2, 3, 4, 5, negative 5, negative 2. And this little point, yeah, it looks like it's 4. So it'll be negative 4, positive 1. Let me go ahead and connect this while I'm here. -3, so +3, -2, -2, so +2, -2, bam, bam. We did that, no worries. For the functions, using the function y equals f of x from number 4 above, sketch the graph of. Recognize this, we have a piecewise function. So essentially for values of x greater than or equal to 0, it's going to look like this function. For values of x less than 0, it's going to look like that function. You already sort of know what's going on, hopefully. So this function, greater than or equal to 0, so I'll do equal, and I'll do this one in purple, and I'll do the other one in orange. 1, 2, 3, 1, 4, 1, 5, -2. And then for the negative one, 1, 2, 3, 1, 4, 1, 5, -2. Okay. And what I'm going to do here is I'm going to do a very exaggerated open interval to indicate that it's the purple graph when x is 0 towards positive infinity, and it's the orange graph from -infinity to 0, but not including 0. What type of symmetry, if any, does this graph number 5 have? It's definitely reflected over the y-axis, symmetric over the y-axis. Yeah. Okay. Okay. How is the graph in number 5 related to the graph of f of the inverse of x for the function in number, for the function y equals f of x from number 4? Okay, from the function 4. So essentially they're asking, how is this similar to this function? This function here is f of the absolute value of x. For the absolute value, if we were to take the absolute value of this function here, we would take the positive x value side, copy and paste it over, and we would delete anything that was to the left of the y-axis. That's what we do here. It's the same thing. It is it. So how does the graph in 5 related to the function of number 4? F sub 5 equals f sub 4 absolute value of x. It's another way of writing it using mathematical terms. You could also just write, this is what the absolute value, this is what f of the absolute value of x would look like. If we were just told to simply graph that, it would look like that. That's it. How to sketch the graph from the graph of y equals x. Erase values to left of y-axis. Copy and paste graph to the right of the y-axis over the y-axis. There you go. It might be annoying, but believe it or not, writing things down like this in your own words really do help submit. The more you're thinking about mathematics in its proper terminology, the better you will be. And also, this is next to being able to explain it. And we all know being able to explain what you're learning is a very high level of learning. I think it's Bloom's taxonomy or something like that. They're always changing things. There's some new name. But if you can explain what you're learning, you really are on point and you really understand what's going on. That's it for pages 11 through 12. I'm going to mark my time, 6:02. That took me a while. 6:08 or 6:28. So it took me 26 minutes to do this. We still have class time. We went through pages 13 and 14 in class. You have these in the notes. Again, if you still don't have these notes, they've been at the school for, I think, the last 3 or 4 weeks at this point. Please don't waste the ink in your parents' printers printing this. I don't even know how you have the patience to print 42 pages. I print it front and back. This is what I get when I print it outright from the printer at school. I don't know why. Just have one of your parents or a cousin or somebody go pick them up off the school and save yourself the hassle. Okay, so I'm going to start pages 15 through 16. I'll try to leave some sort of timestamp, 629 through. Okay. I already did these in class, so I'm not going to do them again. If you have questions and whatnot, please do drop by during tutoring hours, Wednesdays 10 to 11. Remember, in blue, if you're going to be using the color coding, make sure the whole thing's in blue. I'm going to do D again because I don't know if I don't think 1A did D. So I'm going to do quickly, straightforward. I'm going to do C and D, and then I'll jump through. So if you need A or B, try it on your own and consult the solutions, or see me during tutoring or what have you. Let me start off with this C. What am I doing? I'm moving to the right 3. I'm reflecting over y-axis here, and then it's a vertical stretch by 2, or it's going to be double it. So let me sketch my little axes. Yeah. I'm going to do a ghost image of my parent function because I find that more helpful. And I'm also writing the coordinates so I could just double, triple check so I'm not putting the wrong point down. Okay, so 0, -1, 2, -1, 3, 4, 5, 1, 2, 1, 2, 1, 2, 3, dotted lines. Okay. So now what I'm doing now is I'm just thinking about what's going to happen. What am I doing? Okay. Okay, so I'm going to move it to the right 3 units, and then I'm going to reflect it over the x-axis, and then I'm going to stretch it. So I'll do it regularly in pen, and then my final answer I'll try to do in some sort of color for the heck of it, for the visual effect, if you will. Okay, so moving it to the right first 3 units, 1, 2, 3, 1, 2, 3. 1, 2, 3, 1, 2, 3. You obviously don't have to do this like I do. I just don't want to make careless mistakes. And then when I reflect it over this one, and remember, I'm only changing the x values, it's at +1, so now it's going to be -1. This is 3 units to the right, so it'll be 1, 2, 3 units to the left. I'm going to go ahead and draw my line. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8. 2 above. 1, 2, 3, 4, 5, 6, 7, 8. Yep. So that's the first step. We're almost done. Now I'm going to leave the final answer in orange. I'm going to actually use this using highlighters because some of you may not have colored pencils, but you'll have highlighters. So I might as well just stick with the highlighter game. Now I'm going to essentially multiply my y values by 2 because it's a vertical stretch. So we're multiplying the y values by 2. -1, -2, -2. The x's don't change. +2. 2 times 2 is 4. So far, it's what's going on. And 1, 2, 3, 4, 5, 6. 3 times 2 is 6. Okay, there we go, and that's the final answer. Let me make sure, yep. So that's what it looks like to move to the right 3, reflect over the y-axis, and a vertical stretch by 2. Generally, I always find it's easier to, when you're you always start inside parentheses and work your way out. So you do whatever's in parentheses first and then what's outside later. But starting parentheses, it's always better to start on the outskirts of the parentheses and then move towards the variable. I find that works out better. So that's why I'm moving it right 3 and then reflecting over the y-axis versus being vice versa. Here, I'm going to take the original parent function, move it down 5 units. Oh, sorry, we start inside and work out. So before I move it down 5 units, I have to take the absolute value of the y values. So drawing this, and sketch a ghost of the parent function. 3, 4, 5, 1, 2. 1, 2, 1, 2, 3. Okay, so first off, the absolute value of this function, and I'm going to switch it up slightly. I'm going to do this in green. The absolute value, remember we're taking the absolute value of the y functions, not the x function, not the x input values, but the y values. So everything that's a positive y stays put, but everything that's a negative y is literally hinged up and reflected over. So we have some new coordinates to actually deal with here. We have 2 new coordinates to deal with here. Because these coordinates are now valuable, remember when we're treating these like marionette puppets, each string is to a useful coordinate, but now we have 2 more. We have to sort of add 2 more strings here. You can see it. So I'm going to go to the original function and just think about it's crossing the x-axis at 3, 0. And this one looks like it's about -1/2, 0. So the coordinates here, just to keep track of what's going on and put a numerical representation, this is at 3, 0, and this is at about -1/2. We're still not done yet. We have to essentially shift it or translate it down 5 units. That final answer will be in orange. We just shifted down 5 units, that's it. Halfway, so this is why it's good to know it's halfway. So I'm going halfway, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, and that's the final answer. If it helps, I'll put the final coordinates if you're tracking via coordinates. -1/2, -5, -2, -2. I'll just do this one. So at 2, -4. Okay, and that's it for page 15. I don't know why, just so you can visually see that it's page 15. On to the other side. Okay. So I'm going to do E and F. I'm going to discuss G and H, and then I'm going to do I and I already did J. So I'll show you guys J. I know I did J for every class, so that's not necessary. Show, discuss, show, discuss. Okay. And then we are moving along. So looking at this, everything's inside parentheses. So I'm going to augment my input X values. Again, I find it easier to, well, let me rewrite this. Ultimately, it's going to be 2 times X. So it's going to be a horizontal stretch by a factor of 2. And it's also going to be right 1 unit. There's no reflecting over an axis or anything. So ultimately speaking, I don't think it's too impactful whether we multiply the x values by 2 or if we move it right 1 unit first. But just keeping with the notion of sort of outside towards the variable, I'm going to move it right 1 unit. I'm glad I caught myself, and this is the importance of writing down what's going on. I wrote down right, and I even said right, but we know it shouldn't be right. We need to deal with the additive inverse. The additive inverse of number 1, the additive inverse to add to number 1 to get 0 is -1. So another good reason of why it's always good to write your steps down, because I was just going along, but I saw right and I saw that, and I'm like, that's not right. So that's why it's always good. You can catch yourself. We're going to move left 1 unit, and then the multiplicative inverse, right? 1/2 times 2 is 1. So we're going to multiply the x values by 2, sketch the function, do a ghost image of the function. And I'm doing this to avoid making careless mistakes. If you don't want to do said ghost image, feel free to. You don't have to. 3, 4, 5, 1, 2. 1, 2, 1, 2, 3. Okay. Okay. So I will do this in 2 steps just to make sure I don't make careless mistakes. Left 1, left 1, left 1, left 1. Now I'm going to multiply the y values by 2. The y values. 2 times 2 is 4. Shame on me, I caught myself again. I said multiply the y values by 2. You could tell I'm a little tired of doing this. I'm sorry. If you got this down packed, don't waste your time doing it. But if you need to practice, you do need to practice. No pain, no gain, tough through it, or work through it, whatever the expression is. Multiply the x values times 2. So left 1, good job. I need to multiply my x value times 2. 1, 2, 3, 4. So my x is 4, so this needs to now be 8. 1, 2, 3, 4, another 8, because we're going to get a horizontal stretch by 2. And I'm writing this down to remind me it's horizontal stretch. 1, x is 1, 1 times 2 is 2. So we have this one. And I'm going to highlight in orange too. Okay. 1 times 2 is 2. This one here, this is why I drew a more solid line. -1 times 2 is -2. So please be very careful and keep track of what you need to actually be altering and changing. And then -3 times 2, 3, 4, 5, 6. Okay, there we go. And then let's see if it's really what's going on. It moved to the right 1 unit, and then I had a horizontal stretch by a factor of 2. And that's what it looks like. Okay, on to F. We're moving it left 5, and then a vertical stretch on the y-axis by a factor of 3/2 or 1.5. I'm gonna use 1.5 because it's easier to multiply in your head. Let me sketch my x and y axes. I'm gonna do something slightly different. I'm gonna go ahead and augment my x values. I'm essentially, instead of plotting the ghost image of the parent function, I'm just gonna go ahead and plot it, having moved it 5 units left, and then I'll do the transformation. That would be a bit easier for me. So essentially, if it's moved 5 units left, this is gonna be at 0. If this was at 2, 1, 0, -1, -2, -3. And then this was 2 units away. And then if this is at -2, +3 initially, -2, -3, -4, -5, -6, -7. And I'll go ahead and do this solidly. So now what I have to do is I need to multiply my y values by 1.5. Avoid making careless mistakes. Yes, I'm pulling out my calculator. 1.5. So, okay, so double checking. Y values. Okay, y axis. Okay, so -1 times 1.5, -1 times 1.5, 2 times 1.5, or 2 times 3/2 gives us 3. A small vertical stretch. I'm going to go ahead and use the highlighter just to indicate this is my final answer. Here we go, here we go, here we go. Okay, and lastly, yep, 3 times 3/2, or 3 times 1.5 is 3, 4.5. 3, 4.5. I didn't use my calculator. I'm afraid of making mistakes, so there's no shame in my game. Just double checking. What they say in carpentry, measure twice and cut once. I'd rather triple check than have to pull out the wide out. And hooray, that's what we get. Okay, moving on to G and H. The final answer for G was the one in blue. So starting inside, we did a horizontal stretch by a factor of, in this case, remember, it's the multiplicative inverse, so a factor of 1.5. And then we flipped it over the axis and did a stretch vertically by a factor of 3. All right. In red was our original function. In orange was our horizontal stretch by a factor of 1.5, just like what's up here. This is why I wanted to calculate, because I didn't like that I made a mistake here. But this is our transformation after a horizontal stretch by a factor of 1.5. And then in blue is a reflection over the x-axis, and then a vertical stretch by a factor of 3. All I did was just multiply the y values by -3. This one I had to do on graph paper. As students in other classes saw, it did expand well beyond the graph here. So zooming out, okay. So the final answer circled in blue. And let's think about what's going on and how we're doing this. The final answer circled in blue and outlined in pen again. This is the original parent function. Yellow, let's think about what's going on. The original parent function, we have to do a horizontal stretch by a factor of 3. And then we have to move it right 4 units. But before we move it right 4 units, if you recall, that absolute value symbol's there. Remember, it's always better to move towards the x, so multiply the inputs by 3. Take the absolute value of the inputs, and then move it right 4. So we have the stretch, then we took the absolute value. So the initial stretch horizontally by a factor of 3 was here. Then when we take the absolute value, remember we completely cancel out the yellows. That's why it looks like it was crossed out. So what we're left over is with this orange. And then we only take where the positive x values are, and then we copy and paste it over. So that's where we get the other orange. And then we literally move it 4 units over at every coordinate. And this is the final answer. And not that bad. Once you do enough of it, enough practice, it gets there. Okay. I'll discuss J, and then, well, I'll do I, and then I'll discuss J. So here's I. We're gonna move it right 3 and then a horizontal stretch by a factor of 2. So I'm writing 2x right 3. Okay. At this point in class, I would have just told you guys to do it on your own and check with the key. But since I'm here working through it, I might as well. It's a good guess to see how long generally it might be taking students during class as well to keep up. I'm going to move it right 3, and then I'm going to multiply by 2. So based off of this, let me get my parent functions. Or let's get the parent function sketched and drawn. I'm going to move it 3 units right because we've been doing this already. So just so you can see and all that good stuff. Okay, I'm augmenting the x values. So I'm going to be moving it to the right 3. So it's going to be 8, 2. 1, 2, 3, 4, 5, 6, 7, 8. If you notice that method I do with coordinates, I'm sort of doing that in my head. 5, -1. 1, 2, 3, 4, 5. 3, 1, 2, 3, -1. Okay. 1, 2, 3, -2. -1, 0, 1. Okay. Almost kept going for some reason. I thought I was moving 5 units. I think it's all the 5s there. Now I multiply my y values by 2. Remember, multiplicative inverse. What times 1/2 yields 1? What times 1/2 yields 1? It's 2. 2 over 1 times 1 over 2 equals 1. So we're really multiplying the x values by 2. Okay. The x values, I'm reminding myself it's the x values. It might go off the page a little bit, but such is life. I'm sure we can figure things out. If I wanted to, I would have just moved this y-axis over a bit, but it's not the end of the world. The whole point is that we're getting practice. My x values are +3, 4, 5, 6. +1, 2. 1, 2, 3, 4, 5. So that's 10, 5, 6, 7, 8, 9, 10. You see this stretch going on here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Somewhere out here. You all know how to multiply by 2 here. Check the final key for the final answer. I'm sure we all have it down pat. Such is life. Any homework or anything, remember that's why on the supply list I asked you to get your own graph paper. Maybe if you want to do it in a graph paper, if it makes life easier, more power to you. Okay, moving on to the next number. Okay. Just discussing J, I wanted to explore the order. The orange one is if we started with the absolute value and then went left 3. The purplish one is if we went left 3 and then did the absolute value. So anytime you're taking the absolute value or reflecting, that's when it really matters. Generally speaking, just to stay consistent for the whole class, I would move left 3 and then take the absolute value. So if this is the original function, when I move this whole thing left 3, this whole thing moves over, so this is what's left over. So then when I take the absolute value, whatever's left over on the right side is copied and pasted. And that's what we're doing here. That's how we're going. That's it for page 16, 15 through 16. Let's do a timestamp. 6:29 to 6:53. Wow, we're making shockingly good time. I do admit the warm-ups take a bit more time than I care for. So it looks like we won't get to page 20 today. I'm going to go ahead and post those answers and we can discuss that Monday or Tuesday. We won't get to page 20. But I will work through writing the equations of this piecewise function. Okay. These are your notes if you want to, just to look at it. We've done piecewise functions in the last unit. So I'm just going to jump right here. Additionally, Math Bits Notebook, that's a helpful link for those of you that maybe want the extra practice. So write the algebraic functions corresponding to the following piecewise graph. This is really just, do we know how to write the equations of straight lines? Recalling when we did average rate of change and we discussed the difference quotients, we're going to be using that slope formula a lot. And you're always going to need to know essentially how to write the equations of lines because you're never going to be able to walk away from them. Even when we talk about the derivative is the slope of the tangent line to the curve. Well, the slope of the tangent line to the curve is a straight line. There you go. You're always going to have to deal with it. We're going to have 1, 2, 3 equations. This first equation, let me get the slope. I don't know if I trust rise 1, run 2. I trust this well enough. Rise 1, run 2, without having to completely rely on the formula for slope, because there's other things we can do instead of rely on the formula for slope. I'm going to pause. Zoom recording. Okay. Okay, where's my pen? Okay, so do be aware that in terms of the domain, that's an open interval for a reason. From what I can tell, I'm just going to assign this interval here. If it's ever a situation where you can't tell from whatever's graph, because I think this original image was colored, just know if this closed interval goes with this line, then this one has to be an open interval, or vice versa. If this is open, then this one has to have a closed interval. Just checking my slope, rise over run. I rise 1, I run 2. So my slope is 2 over 1. Here my slope is 0. It's always good to get the slopes done. 1, 2, 3, 1, 2, 3, 1, 2, 3. So here I'm going to say my slope is 3. Let me triple check. 1, 2, 3, 1, 2, 3. It's always good to double check. Then we're going to use our piecewise formulas. I'm going to just color code them in orange. If you don't recall this formula, it's the point slope form of an equation. Y minus y equals m times x minus x. And then I just throw in subscripts. If you ever forget your piecewise formula, it's a take on the formula for slope, where I just toss these in parentheses. I get m times the quantity x sub 2 minus x sub 1 equals y sub 2 minus y sub 1. The reflexive property tells us we can sort of spin around at that equal sign. Y sub 2 minus y sub 1 equals m times x sub 2 minus x sub 1. And then the last step, we have to get rid of these subscripts for these two, because we want actual equations. If you plug in numbers for both these y's, you're not going to get an equation, you're going to get a number. Y minus y sub 1 equals m times x minus x sub 1. And how do I remember to get rid of y sub 2? Well, it's the second one. Additionally, we all remember the formula for slope. When I distribute this m, I'm going to get m times x, and I'm going to get m times some number. So I just remind myself that the first x is the variable. So this is the number we're plugging in. I will write this above just to use for reference. Okay. Generally, it says your first coordinate. It doesn't matter which one we use because they're the same. I'm going to choose A because it's easier numbers to plug in. So here the equation, I have y minus 0 equals 2 times x minus negative 4. Keep flip change, positive 4. So my first equation, remember we do left to right, top to bottom. It's either going to be 2 times x plus 4 or 2x plus 8. I'm going to go ahead and write 2x plus 8. Now let's think about the intervals. In this case, it's a closed interval, so this doesn't go on forever. It's for values of x from negative 4. So x is greater than or equal to negative 4, but x is less than negative 2. Notice I didn't do less than or equal to, I just said less than. So it looks like this line from values of x equals negative 4 up to negative 2, but not including negative 2. Now I'm going to choose yellow. I'll do red. I'll do black. Black's always good enough. I'm going to do this one in black. And I'm going to make the decision to keep this interval solid. 1, 2. So we know the equation is y equals 2. For values of x from negative 2 to positive 1, let's triple check. Negative 2, positive 1. It's included, so for values of x greater than or equal to negative 2, and for values of x less than or equal to 1, because it's included in negative 1. Next, I'll do this one in purple. And I'm going to do an open interval here to really identify that it's not included there. Here we have our slope of 3. And I'm just going to choose 1, 2 with a slope of 3. I'm glad I stopped myself and triple checked. Slope is 2, slope is 0. This is a very good opportunity for you to develop confidence in yourself. If you knew the slope was negative 3, why were you second guessing yourself? There comes a time when you need to stop assuming you don't know anything, because believe it or not, you actually know a lot of mathematics. I like when I make careless mistakes, because it's an opportunity for you to reflect and say, hey, I actually do know what I'm talking about. I'm going downstairs, so my slope has to be negative 3. I was focused so much on making sure I kept track of the numbers, but that's why it's always good to write your notes down and double, triple check as you're going. So we're going to have a slope of negative 3. I'm fine with using these coordinates, 1, 2. I'm going to do something where I'm going to use both these coordinates, and you'll see we get the same equation. Just in case some of you were like wondering, does it really matter which coordinates do we choose? So for this one, I have y minus 2 equals negative 3 times x minus 1. And then on the other side, we have y minus negative 1 equals negative 3 times x minus 4. And once I simplify, I should get the same equations. If I don't, it'll be fun exploration, won't it? Okay, let's see. Y plus 1 equals negative 3x plus 4 times 3. That's quite something. Well, let's see what's going on. Yeah, it's working out. Let me just go with it. 4 times 3 is 12. I have y equals negative 3x plus 11. So let's look at this and see if anything crazy is going on. We should have gotten the exact same equation because it's part of the same line. So the first thing, if this ever happens, is let me make sure I wrote the numbers down. Let me make sure I wrote the equations down. We do have an opportunity for fun exploration. Y minus 2, that should be there, that's there, equals negative 3 times x minus 1. Positive 1, positive 2, it worked out just fine. 1, 2, 3, 4, negative 1. Y minus negative 1 equals negative 3 times x minus 4. That's it. So let's see if I make careless mistakes in how I distribute it. Negative 3x, positive 3, y minus 2. When I add 2 to both sides, I get 5. Negative 3x, 3 times 4 is 12, that's a positive 12. When I subtract 1 from both sides, I get 11. This is such a worthy exploration. I'm going to actually take this to Desmos and graph both terms because I'm very curious. Because it's part of this equation, they should exist. So we're going to take a very helpful diversion, and we do need to take our time to figure out what's going on here. Remember, a big part of math is exploring what's going on here. Let's take the time to dissect this. Okay. Let's move that there. So I'm going to type in, I'm going to type it in 2 different ways. Minus 2 equals, so you can see there's no real difference here, equals negative 3 times the quantity x minus 1. And then we have y equals negative 3x plus 5. Okay, so you can see it doesn't matter. We can leave it technically like this and it's still just as good. It's the same equation. So with that, I'm going to get rid of this and I'm going to just type in, it would be reasonable. Let me type in y equals negative 3x plus 11. So we already know definitely something's going on. I definitely want to get to the bottom of this. Y minus, that should definitely be y plus 1 equals negative 3 times x minus 4. So oh, what fascinating the dots. As far as I know, I didn't make mistakes in solving for the equation. It's just that these equations are different. So I want to get to the bottom of why they're different. It has to be the slope. It has to be. That's got to be the only reason why they're different. So looking at this, I counted the slope. So I'm going to calculate the slope. Because if anything, it could be some miscalculation in terms of counting. X sub 1, x sub 2, x sub 1, y sub 1, or negative 1, x sub 2, y sub 2. Slope equals negative 1 minus 2 over 4 minus 1. This isn't going to be 3. Negative 3 over 3, negative 1. That's why it didn't come out right. Oh, snap. I'm looking at how much time I wasted, but I'm very happy to have this opportunity. So if you got this, hopefully you sped past it. Because this is what's going on in my world. I went down 3 and right 3, so I should have done negative 3 over 3. And I would have saved myself so much time. The good thing is I didn't write my final answer. In doing all these explorations, I certainly got the review workout of doing all kinds of things, knowing that they should have been the same, but they weren't. When I go down 3 and right 3, it should be 3 over 3. I wasted time, but I still didn't write down the wrong answer. So for those of you that had that the slope was 1, good job, bravo to you. For some reason, I'm choosing to take the long route today. It's been a very long day and it's 7 p.m. But I'm glad I figured that out. Again, you can fast forward and move through things all you want. Please take advantage of that. Now with my slope being negative 1, which I figured out here, verified, I'm going to do these again just to verify and show you that they have to be the same. Except I'm going to replace negative 3 with negative 1. So I have y minus 2 equals negative 1 times x minus 1. I have y minus negative 1 equals negative 1 times x minus 4. Let's triple check. y minus 2 equals negative x plus 1, y equals negative x plus 3, y plus 1 equals negative x plus 4, y equals negative x, subtract 1 plus 3. Hooray, finally, Reese. So again, it really doesn't matter the coordinates you choose. You should get the same thing whether you choose this coordinate and that coordinate. If you get something wrong, it's probably something wrong with either how you typed it down, with the slope. If the slope came out to be, what was that, -3 again, then I would just think there's some weird embedded typo, but it wasn't the case. I just miscalculated my slope. But the good thing is I'm almost done. And I'm gonna go back and do this in purple. My last equation, y equals negative x plus 3. I actually don't need that. You don't put y in here because y is already outside, right here. So y equals negative x plus 3, comma, it's from -1 to +4, throw x in the middle, not including -1 because it's open, but including values of x when x is 4. Hooray, hooray, hooray. I would do a timestamp, but I went way over more than I should have. Yep. That's it for page 17. I'm going to stop here because that would have been your class time. We will begin on Monday/Tuesday going through page 20. If you have any generic questions, send me an email. I will be checking my email. But hopefully some of you is, if you can work through this easily, you can use this as an asynchronous learning day so you can maybe focus on other things. Make sure you turn your homework in online if possible. If not, you need to be ready at the beginning of class to present your homework. Yeah, that's gonna be it for me today. We'll begin this Monday and Tuesday. Goodbye, everyone. Have a wonderful day. Stop recording.